Hello, good day, viewers. Someone asked me a very important question, which tends to be underrated. Why do we have a constant of integration at the end of every integration? And why is the derivative of constant equal to zero? I think let me start with the derivative of a constant. Generally, if you have a function like x raised to the power of n, right? The derivative of x raised to the power of n with respect to x is equal to nx to the power of n minus 1. Nx to the power of n minus 1. So let me give you an instance. Let's assume we have y equal to 3x squared plus 2x maybe minus 5. This is a function, right? If you differentiate this dy over dx, it is equal to, this 2 will drop down to multiply 3. We have 6x. 2 minus 1 is 1, so you don't even have to write 1 here. Applying this formula, plus, naturally we have 1 here. It will drop down to multiply 2. We have 2. Then 1 minus 1 is 0, so it will be x to the power of 0. And x to the power of 0 is 1 according to one of the laws of indices. Any number raised to the power of 0 is equal to 1, provided that number is not 0, right? But the moment you differentiate constant, you get 0. Therefore, you don't even have to include it. That is the first question. Why is the derivative of a constant equal to 0? So if that is the case, I'm only going to consider that constant negative 5, assuming that y is only equal to negative 5. Why is the derivative of y with respect to x of this to be equal to 0? That's what we want to confirm. We are going to apply the same thing here. If you look at this is constant without any variable attached, but naturally we have an x to the power of 0 here, right? Because I told you x to the power of 0 is 1. So this is 1 times negative 5. So if you apply the same principle here, for which 0 here is equivalent to n. So n will drop down to multiply. So the moment 0 multiplied negative 5, it becomes 0 times negative 5 times x raised to the power of n minus 1, 0 minus 1. So this will be 0 times this is 0 to the power of what? Times x to the power of what? Negative 1. But it doesn't matter. 0 times this one will make it 0. So this is why we have the derivative of constant to be 0, because naturally the variable attached to that constant has an exponent of 0, and the moment that 0 drops down to multiply the constant, everything becomes 0 at that point. So therefore the derivative of constant is 0. Going back to why do we add constant of integration at the end of every integration? I'm going to explain these two together. I would like to bring derivative here and antiderivative to the other side, because they're opposite. Once you have a function, you differentiate it, it changes, right? But if you integrate that new function, it will give you back the original one, because they undo each other. So if y equals, should I even use y? No, let me use the function itself directly. If you have x to the power of n, d over dx of that function, x to the power of n, will be what? Nx to the power of n minus 1. But if you have x to the power of n, the integral of that function x to the power of n will be equal to what? X to the power of n plus 1 divided by n plus 1. Whatever the new exponent is, you have to divide by that. So if this is the function, remember we do add the constant of integration, and that is the main question. Why do we add this constant of integration? This is a number, right, in the set of real numbers. So let me start here. Let's assume we have a function like 2x squared plus 5. 1. Let me bring 2 here. 2x squared minus 3, right? If you differentiate this d over dx of that function f of x, this is our function. This 2 will drop down to multiply 2, we have 4. Minus 1, you have just x here. Derivative of constant is 0. If you do the same thing here, d over dx of that function will give us 2 times 2 is 4. 2 minus 1 is 1, so this is just x. Derivative of constant is 0. If you observe, they have the same derivative, right? This. But the function, they're entirely different because they have different constants. Therefore, even graphically, they are not the same. So what happens if we decide to integrate these two functions? If you integrate this, we expect to get this back. Likewise, this one. So let us do the same thing. Our function is what? 4x. We want to integrate it. If we integrate this, we expect to have either this or this back. But remember, our main concern is on the variable, so we can bring 4 outside. So this is the same thing as 4 multiplied by the integral of just x. Remember, with respect to x, sorry, we should have dx here. If you integrate this, you know naturally it has a power of 1. So let me just write it here, for which our n is 1. So we have n plus 1, 1 plus 1, making 2. So this is 4 multiplied by x to the power of 2 divided by 2, right? Because whatever you have here, it will be the same thing. You will divide with n plus 1, 2 and 2. All right. 2 can divide 4 exactly 2 times. So this is what? 2x squared. But this is 2x squared plus 5. This is 2x squared minus 3. But this is not giving us what we have initially. So since we don't know the actual constant, is it negative 3 or 5? We have infinitely many of them that have different constants but the same expression, right? So you can attach constant of integration. And this constant of integration could either be this one or this one. If you want to find which one is this, you can use initial value, right? For instance, if y is equal to 2x squared minus 5 for this one, what will be the value of y when x is equal to 1? For instance, if x is 1, we have 1 squared is 1 times 2 is 2 plus this is 7. So you can see that 1, 7. So the moment you substitute this point in here, the constant will be 5. You do the same thing here. So since we don't know which constant is that, we can replace it with c, for which c belongs to the set of real numbers. So this is the reason we attach the constant of integration, because we have infinitely many constants. It depends on which one. If you have an initial condition given to you, you may substitute, because this is y equal to 2x squared plus c, you substitute y equal to 7 and x equal to 1, simplify, solve for c, it will surely give you 5.